Hi everyone, my name is Jack Shaw and I'm the District Manager for the UK and Scandinavia in Regenesis. And as part of this short presentation, I'm just going to take you through who Regenesis are, what we specialise in, and what you can expect when you're working with us. So first of all, Regenesis, we are a company that specialises in the research, development and commercialisation of injectable substrates to remediate contaminated groundwater. So our focus is very much on groundwater. We've been around for a while, so we were first established in 1994. And before Regenesis, nobody had injected proprietary reagents into the ground specifically for groundwater remediation. So we were the first company to research, develop and commercialize these different injectable substrates. Since then, we've released a bunch of different technologies that can address chlorinated solvents. So be that using technologies such as HRC, our hydrogen releasing compound, or our inoculum, BDI, to facilitate the reductive dechlorination process in environments of lower permeability, such as clays. We've also released a series of appropriately soluble electron donors, such as 3DME. 3DME is a technology. Once injected into the subsurface, it will continue to release hydrogen for up to 5 years after a single injection, creating a stable environment to grow a large microbial consortia. So you break down that contamination in situ. And more recently, we have released a series of colloidal products. The first of this was PlumeStop, a liquid activated carbon. PlumeStop is a technology that comprises finely milled granular activated carbon that we've milled down to 1 to 2 microns. So that's the size of a bacterium, that's the size of a pore throat. And we've coated it in a proprietary dispersion agent so it moves and behaves like a colloid. So blood is a colloid, wine is a colloid, milk is a colloid. As a technology, it flows very freely in the aquifer. This is crucial. You want your products that you're injecting into the subsurface to distribute well. And with PlumeStop, when injected into the subsurface, you can paint the aquifer with carbon. And when you pair it with an electron donor, such as HRC, you can create an environment where you get desorption of chlorinated solvents and then enhanced reductive dechlorination thereafterwards. Furthermore, we've most recently released a technology called S-micron ZVI. So it's a sulfidated zero valent ion product. Again, it's part of our colloidal range. We have milled granular activated carbon down to 1 to 5 microns and coated it in a proprietary dispersion agent to create a suspended colloid that can then be injected into the subsurface. Other technologies and other sorts of contaminants that we can also address are petroleum hydrocarbons. Again, this comes with a wide range of different technologies depending on your site. ORC Advanced, for example, our oxygen releasing compound, once injected into the subsurface, provides a controlled release of oxygen for up to 12 months to accelerate the natural attenuation of petroleum hydrocarbons in situ. We also have a range of safe to use chemical oxidants. Regenox, for example, is a chemical oxidant that here within the UK and certainly across Europe is used every working day. So it's used on a wide variety of projects, lots of different kinds of sites. And one of the key points with Regenox is, unlike commodity chemical oxidants, it's very safe to use. You don't have any issues with increasing pressure or temperature when you're mixing this product, and so it can be used on sensitive sites and also can be used in and around existing underground infrastructure such as pipes, cables or underground storage tanks. We also have technologies like PetroCleanse. It's an enhancing desorption agent that can improve the efficiency of free-phase hydrocarbon recovery when using a pump and treat system. So PetroCleanse is all about desorbing contaminant mass that's stuck onto the soil, pulling it into the groundwater so it then can be recovered using a pump and treat system. Finally, one of our more recent products introduced to the hydrocarbon line is Petrofix. It's a finely milled granular activated carbon that is designed to treat very high levels of TPH in situ. It can really be a single hit, so you're not having to do multiple applications like you occasionally would do for chemical oxidation, for example. But instead of going down the aerobic route for biological degradation, which you get with ORC, it goes down the anaerobic route, and couple this with absorption can provide rapid reduction in contaminant levels in the very near term. In terms of where we are across Europe, so our head office is based in Ireland, in Dublin, but we also have regional offices across the UK. So I'm based in the southwest in a place called Bath. We also have offices in Belgium and in northern Italy. And to date, we've done some 3,000 projects across the EU. Consequently, we've seen lots of different types of sites. Internationally, though, since our 20+ year tenure, we've done well over 26,000 projects worldwide. So chances are, if you're looking at a site with hydrocarbon issues or chlorinated solvent issues, we'll have seen that before. In terms of our approach, so as a company, we're actually quite consultative. Typically, the earliest that you could get us involved is midway through the supplementary site investigation stage. So, for example, say you have a site, you've done an initial SI, and the thought is some sort of remediation is going to be required. And you are now designing that supplementary site investigation to better delineate the contamination on site. Often I'll have clients speak to me, say, this is the situation, we're going to do this site investigation. We'd like to explore the in situ route. Is there anything extra we can look for during this early stage so that when the final site investigation, that final phase 2 report is completed, they're not having to go back and look for more information? We can help advise you on how to sharpen up that supplementary site investigation. What's more common, though, is once the site investigations have been completed, the consultant has established that there is a risk to groundwater with regards to contamination, or if a environmental contractor, a remediation contractor, is tendering for works, we can review the information that has been gathered or has been given to you and evaluate the site to see if it is suitable for one of our technologies. Now, it's important to mention that Regenesis isn't a panacea for groundwater remediation. There's going to be sites out there that we can't help you with, but we'll be very upfront with that. It's why this consultation period is important. And we see lots of sites. So annually, as a company internationally, we review and design well over 1,800 sites worldwide. Now, if this site isn't correct, we will say why it isn't and perhaps point you in the direction of someone that may be able to help you. If it is suitable, depending on your contaminant mix and depending on your site, we will then start to explore different technologies, not only for the conceptual site model, so the based on the technical evaluation alone, we'll also ask you, what are your commercial aspirations for this site? Is this a site where there's a transaction that's going to happen, so you need to clean it up very quickly? Or is it a site where the current owners have no intention of selling the site, but they're actually looking for a remediation strategy that doesn't disrupt their ongoing commercial operations? And because we've seen so many different sites, we have seen pretty much everything. And we don't just look at large Department of Defense or industrial manufacturing sites. We often see lots of smaller gas stations. Here in the UK, we're happy to evaluate small domestic oil spills that are in somebody's back garden. Really, we see quite a range of sites that where you can use these technologies. So let's assume that this site is a contender for our technologies. We'll then help you with that technology selection. So like I said, based not only on the technical information that you've sent to us, but also the commercial pressures around that particular project. We'll then issue you with a remediation design. So that will include how to apply the product, what you can expect in terms of cleanup, and the cost associated with those technologies. Now, something else we do offer is product implementation. So we can offer a turnkey service for our technologies. So we have a division called RRS, so Regenesis Remediation Services. RRS covers the whole of Europe and indeed all of North America as well. And this enables us to offer you warranties and guarantees for different projects. And it also helps us ensure that our designs are applied to specification. And if there are site conditions, real world conditions that don't allow for that specified design to be applied, then we have engineers that are specialists in this that can react to those site conditions without compromising treatment efficiency. And really, we have a vested interest in making sure every project where our technologies are used goes well. And this is one way of us ensuring and guaranteeing that this is so, that we have some control over the application works on site. Now, not every project requires this, not every site is this possible, but it is something that we offer all of our clients. And then finally, once the product has gone into the ground, once these technologies have been injected, something we're very keen to be involved in is the post-evaluation. So during the validation and verification phases of the works, do keep us involved, do send us the data. We like to see it when sites are going well. If there is something within the data that you're not so sure about, these are the sorts of sites that we look at every day, all year. So we can evaluate it, we can check things are going well. And if things aren't performing as expected, it gives us, Regenesis, the opportunity to go in and maybe correct or alter the recalcitrant areas of the site. The key thing is, though, for that post-evaluation phase and the design and technology selection and site evaluation, these aren't services that we charge for. The only point that where we do charge is the product implementation and the sale of these products and technologies. So do think of us as a resource that you can call up even just to bounce ideas off of. So in terms of how these products can be applied into the subsurface, there's a number of different ways. The first being direct push injection. So this is where you take a hollow stem rod, and on the end of this injection rod is a non-return valve. You hammer this rod into the subsurface at your required depth, and then you can inject your technologies across the required horizon. And this video that you can see here is with a client of mine called RGS Nordic. This is actually a site in Finland where we had to get down to some 15 meters below ground level in a moraine. So they were using quite a big rig to hammer these rods into the subsurface. Here in the UK, so this is another picture you can see on the left is a site in London where they're treating some river terrace gravels. You can use a small Terrier or Beretta rig to get these sorts of rods into the ground. So you don't always need something quite as big as this. For sites where you're doing multiple applications, it's often required for chemical oxidation jobs, or certainly jobs using something like Petrofix, which is an enhancing desorption agent, or for sites where you're looking to treat a bedrock, for example, where direct push injection wouldn't be an option, then we would recommend down well injection. So this is where you install a series of injection wells. These injection wells, they're no different to your standard monitoring wells. The only difference is from 0 to 1 meter below ground level. When you're constructing them, we ask for you to backfill it with cement rather than bentonite. The reason for this is that we will be injecting these technologies, these products, under pressure. And if you don't have that concrete seal, it can be the case that when injecting these products under pressure, they will follow the path of least resistance. So they will travel upwards adjacent to the standpipe, and then the product will start to erupt to the surface. And we call that daylighting. So to prevent that, we ask for this concrete to be applied in that top meter so it creates a better seal to minimize any daylighting that may happen. Other than that, same construction as you would a standard monitoring well. Typically, we would recommend a 50 mil internal diameter if we're looking to apply the product over multiple lifts. So if we're looking to use a double packer assembly, then we'd need a minimum of a 75 mil internal diameter. Also, for a number of our technologies, you can apply them directly into the base of an excavation. The key thing, though, is that this excavation must extend into the top of the groundwater. So you can see here in this short video, this now still image, it does. The reason for that is that all of these technologies need to be hydrated in order for them to work. So that excavation must extend into your top of your groundwater or your perched water table. And finally, for certain sites, you can apply our products EX-SITU to reduce contaminant mass in soil. Now, this is very much the exception rather than the rule, and we would always recommend that you undertake maybe a small trial on your site before you do this. The reason for it is it's down to how well you can distribute that product within your impacted soils. So this video here, this image is from a site in southern Sweden in a place called Malmo. Here they are spraying a chemical oxidant into soils that have been impacted with a jet fuel. Now, this site was a contender for this sort of remediation because this fuel distribution terminal was built on reclaimed land. So we were dealing with a very homogeneous sandy silt. So we could mix it well, in this case using an alu bucket, so we could ensure that we got good distribution of this product across the soil. If you were looking at trying to do this with, say, a clay or an alluvium, then this is likely not going to be a contender. You're not likely to be able to do this with our technologies. We always recommend to trial this because every site's different, so the geology is going to be slightly different. Also, how each individual client mixes the soil is going to be slightly different. So that's why we'd always recommend undertaking a trial initially.